Okay, this question starts, I've got f of x with some k's in it. Okay, and the first thing I have to do is this, put it in that form, in other words, complete the square. Okay, now we're getting towards the end of the paper, so this is maybe not totally straightforward, but you look, we've just got 1x squared, so it's not the dirty bracket method, so that's not too bad. So we just have to remember, you might want to just remind yourself what you'd do if this was not 4kx, but if that was something like 12x, yeah? Okay, so how do we set up our squaredy bracket? It's clearly going to have an x in it. What do you do with the thing in front of x and put it here? Think with numbers first. And then what automatically comes after the squaredy bracket, it's always minus something, and then the bit at the end doesn't bother you at all to begin with, you just put it plus the same thing. So you get that set up, and then you simplify a little bit, and p and q turn out to be in terms of k. Don't worry if q's not particularly tidy, it may have k's in it and numbers, you don't care. Alright, so although the k's look like they make it harder, they don't really. Okay, then given that this equation has no real roots, trigger words if ever there were one. No real roots. Okay, what does that mean? Well, I'm going to have to give it away. It's the discriminant. If you don't yet know that when it talks about two distinct roots or equal roots or no real roots, that you start by writing b squared minus 4ac, then you need to learn that. Okay, and b squared minus 4ac is not enough on its own. In this kind of question, when we know the number of roots, we need to say how b squared minus 4ac relates to naught. It might be greater than naught or equal to naught or less than naught. Okay, you have to put the correct symbol here straight away, please, not as an afterthought later on. And we've got to find the set of possible values of k. Okay, so this is our starting point. Okay, b squared minus 4ac, well, I've got my a is my coefficient of x squared, so a is going to be an easy number. B is this bit here, and they've kindly put this in brackets, so the plus thing at the end, that's my c there. So we set up b squared minus 4ac, okay. Set of possible values is a bit of a hint that it's going to be an inequality that I solve rather than particular values. So you're likely to have here a quadratic inequality. All right, the classic 4 marks for a quadratic inequality. Okay, that might be just a linear inequality, but I would suspect it's quadratic. So if it is a quadratic inequality, make sure you give me a graph, and you either shade the ends or the middle, and you give me the solution in an appropriate way. Okay. All right, then, given that k equals 1, so now I know what k is, so I can take a deep breath and sigh of relief and say, okay, this 4k is just 4, and this bit here is just 14. So I can write down the equation knowing exactly what it is, and we've got to sketch the graph of that. I mean, some of the work you've done before may help. So if this k equals 1 is in your set of values, then you know it has no real roots. You've already completed the square on it, though you may want to do that again with the numbers. You might feel a bit safer doing it with the numbers than you did doing it with the k's in it. Okay, so you know where the vertex is. Any point where the graph crosses a coordinate axis, well, it's bound to have a y-intercept when x is 0. I've just given that away. And it will also have x-intercepts if y equals 0. Okay? But you may already know from the work you've done, whether you will already know actually, if it has no real roots. So therefore, if it turns out that this k equals 1 is a value that makes b squared minus 4ac what you said it had to be for no real roots, then you're not going to waste time trying to find y-intercepts if it hasn't got any. Okay? And the position of the vertex, okay, if you've got a vertex and this turns out that the y-coordinate of that vertex is above the x-axis, you're not going to muck around trying to find the x-intercepts, I hope. All right, so the earlier work can help you with that last bit. Okay? Good. Yes, okay, that's the end. Okay, I mean, I'm not trying to imply that this will happen. It may well be. I mean, 3 marks, you're expecting maybe to do a little bit more than show a vertex and a y-intercept. So I wouldn't be surprised if it does solve and factorize, and then, yeah. Okay, have fun.